In this video, I am going to explain you about carbon resistors. Now, why we are using carbon to make resistors? Why can't we use metal? The problem here is with metal, it is having lower resistivity. So only we can produce resistors with lower resistance. For example, 1 ohm or 2 ohm or 5 ohm with metals. To make higher resistance, we either have to use thin wire or longer wire, which is practically difficult and even expensive. So we are going to use powdered carbon. So carbon lies in between conductors and insulators. So this is the best material to produce higher resistances. Now how we will produce the resistors? We will powder it and then we will cast in the form of cylinder. So this now will have a resistance. We will find the value of resistance and after that we have to mark the value of resistance over here. So this is powdered carbon made in the form of a cylinder and it is attached with metal jacket on both the ends. So now this is a carbon resistance. Let's say its value is 48,000 ohm. How to mark it on this ohm, on this resistance? Either we can mark with numbers 48,000 and with unit. But the problem is this number cannot be analyzed with everyone because it's a small resistance, right? You can just go to Google and search about the resistance. You can see that the size will be very small, so that when we are representing the number over here as written, then it is very difficult to read, and by the time this resistance gets shipped to other location, these numbers can get erased with the transportation. So there is a chance for to take the value of resistance with error. So why, instead of avoiding this kind of error, like while reading difficulties and this kind of problems with erasing the numbers, we are going to use color code to represent the value of resistance. For example, 48,000 will be now represented with 3 color codes. So in a resistance, let's say this is resistance, and now it will be having 3 color codes. First one, this one, then this one, then this one. One more color code it will have at the end. Okay, so these 3 numbers are basically representing the value of the resistance. Let's say a number can be represented as x, y into 10 power z plus or minus a value, because the resistance will not be a fixed value. That may be subjected to a slight variation. For example, 100 ohm, though we can write it as 100 ohm, this value will be sometime 105 and sometime 95, which means there is a 5% tolerance. This, though it is made with 100 ohm label, this you can also expect 105 ohm delivery or 95 ohm delivery with the same resistance. Now this is called as tolerance. It is 5% tolerance here. Clear? When it is 10% tolerance, what can be the values? 110 and 90. Okay, anyway, leave it. Basically we need to first get this number, then I will explain about tolerance. Now these numbers are represented as 3 colors and these numbers are xy into 10 power z. Now how to get the value of x? That is from the first color. Now how to get the value of y? From the second color. Now how to get the value of z? From the third color. Now 48,000 ohm can be represented as 4 is represented by yellow. Then 8 is represented by gray. Then 10 power, this is 10 power 3, right? 10 power 3 is represented by orange. Now if there is a gold strip at the end, gold colored strip, then we can expect a, then if the tolerance is 5%, if the tolerance is 5%, we can expect even a gold color strip at the end. Okay, so this will be the color code. 4 color it will be having yellow, gray and orange. So yellow, gray and orange is representing the value is 48,000 ohm. But the last colored strip is representing the tolerance. Clear? Now there is an easy way to memorize this thing. You can memorize this as first one is B, right? So B rho of grade Britain has very good wife wearing gold and silver necklace. BB Roy of Great Britain has very good wife wearing gold and silver necklace. So this way you can mark the values. B first we represent of 1, then 0, then second be 1, R 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, white 9. Now this table you don't need to actually memorize. This is nothing but 10 power. So let's say if you are having black in the third one, instead of memorizing in this way, you can use from here itself. So just raise the value to 10. So if it is black is nothing but 0, so 10 power 0. Let's say if it is yellow, instead of memorizing it as 10 power 4, you can take it as yellow from this table is 4. So it is 10 power 4. Clear? If it is blue, then instead of memorizing it as 10 power 6, just learn this table, this column 6 it is. So raise the power of 10 to 6. Clear? I hope it is very clear with you. First strip is first color. First colored strip represent the first number in this thing, xy into 10 power g. So here yellow is 4, gray is, what is gray? 8, 48. Now next one is 10 powered. What is the value of, what is the color of third strip here? That is orange. So orange is 3. So that is 10 power 3 here. Okay. And the last color represents the tolerance. Here in this case gold. Gold means only 5% tolerance. So this basically can be taken as purity. Gold means highest, the purest one. Silver in between. Color is less pure. So higher the impurity, higher will be the tolerance. This is less impure. So having the gold colored resistance will be expensive because it is made with precision. That will be having very less tolerance over parameters like temperature and other things. Clear? Thank you.